Chapter 22. The flowchart that runs itself. An order confirmation at Nimbus required 5 things to happen in sequence: charge the card, send the confirmation email, notify the restaurant, update the inventory, and log the transaction for accounting. If step 3 failed, if the restaurant notification timed out, steps 1 and 2 had already happened. The customer was charged, the email was sent, but the restaurant didn't know the order existed. Leo had a name for this category of bug: the partial success. Everything worked, he said, except for the part that mattered. How many times has this happened? Maya asked. 11 times in the last 2 weeks. We caught most of them from angry calls to the restaurant. 2 we found in the logs, after the fact. So we have no coordination, Priya said. 5 steps, running as a script, with no guarantee they all complete, or that they complete in the right order, or that we know which one failed. Leo pulled up the code on the projector. It was a Python function, 50 lines, 5 sequential API calls, a single try except block around the whole thing. If anything in here raises an exception, we get a 500 and the customer sees an error. But charges and emails don't roll back. We need a workflow, Maya said, something that tracks each step. AWS Step Functions orchestrating workflows. AWS Step Functions is a serverless orchestration service that coordinates the steps of an application as a visual workflow. Each step is a state in a state machine. Instead of a Python script that runs top to bottom and crashes, you define the workflow as a JSON YAML state machine. Code example omitted for narration. Each state can execute a Lambda function, the most common pattern, execute an ECS task for longer running work, wait for a specific time or event, pause the workflow until something external happens, choose a path based on conditions, if-else logic, run parallel branches simultaneously, retry on failure with configurable backoff, catch errors and route to error handling states. Step Functions manages the execution state durably. If step 3 fails, the execution pauses at step 3. You can inspect the failed execution in the console, fix the issue, and restart from step 3 without repeating steps 1 and 2. State types, the building blocks. Task, execute an action, call a Lambda function, start an ECS task, call an API. This is where real work happens. Choice, branch based on conditions in the input data, like an if-else in code. Parallel, run multiple branches simultaneously and wait for all to complete. Map, apply a set of states to each item in a list. Process 50 restaurant menu items in parallel. Wait, pause for a specified time or until a timestamp, useful for scheduled delays. Pass input to output without doing work, used for data transformation and testing. Succeed, fail, terminal states that end the execution. For the restaurant onboarding, Leo designed a workflow. 1. Validate license, task, Lambda. 2. Import menu, task, Lambda, with 3 retries. 3. Parallel branch, set up payments, task, Lambda. B. Create IAM role, task, Lambda. 4. Send welcome email, task, Lambda, waits for parallel to complete. 5. Notify sales team, task, Lambda. Steps 3A and 3B run in parallel. They don't depend on each other, and running them simultaneously saves time. Standard versus express workflows. Step Functions offers 2 workflow types. Standard workflows. Maximum duration, 1 year. Executions are durable. State is persisted, can be inspected and audited. At least once execution. Each task runs at least once. Priced per state transition. Best for long-running important workflows, order processing, onboarding, payment flows. Express workflows. Maximum duration 5 minutes. Higher throughput, up to 100,000 per second. At least once or at most once. Configurable. Priced per duration, like Lambda. Best for high-volume, short-duration workflows, real-time event processing, IoT data ingestion. For Nimbus's restaurant onboarding, standard. It's important, durable, may take hours if manual steps are involved. For Nimbus's real-time order status updates, express, high volume, short duration, less critical. Event-driven architecture, the bigger picture. Step Functions is one piece of a larger pattern, event-driven architecture. Instead of services calling each other directly, tight coupling, services emit events, and other services react to those events. We've seen this throughout the book. Orders placed, SNS publishes event, SQS queues delivered to consumers. S3 file uploaded, Lambda triggered to process it. DynamoDB record changed. DynamoDB streams, Lambda updates a cache. Amazon Event Bridge, formerly CloudWatch Events, is the advanced event bus for this pattern. It routes events from AWS services and your own applications to targets, Lambda, SQS, Step Functions, etc., based on rules. Event Bridge allows loose coupling at an architectural level. The order service publishes order.placed events without knowing who's listening. The analytics service, the notification service, and the loyalty point service all listen independently. Adding a new listener doesn't require changing the order service. When Step Functions is the right tool. Step Functions excels when you have multi-step workflows that need to track progress across steps. Human-in-the-loop processes. Step Functions can wait indefinitely for an external event, like a human approving something, and then continue. Error handling at scale. Built-in retry, catch, and fallback logic across many steps. Auditable processes. Every execution records every state transition. You can see exactly what happened and when. Complex parallel or sequential logic. The visual workflow makes it easier to reason about than equivalent code. Step Functions is overkill for simple two-step processes. Use it when the coordination itself is valuable and the failure scenarios are important. Strengths and limitations. Why Step Functions is powerful. Visual execution history. See exactly where a workflow is or failed. Built-in retry and error handling. No custom retry code. Execution survives service restarts and outages. Direct integrations with 200+ AWS services, not just Lambda. The visual workflow is self-documenting. Where it gets complicated, standard workflows are priced per state transition. Complex workflows with many states can become expensive at scale. The ASL Amazon States Language JSON format has a learning curve. Maximum payload size is 256 kilobytes. Large data must be passed via S3 references, not directly through the workflow. Long-running workflows with many manual steps require careful timeout configuration. Summary Step Functions orchestrates multi-step workflows as state machines. Each state can run a Lambda function, execute an ECS task, wait, branch, or run parallel steps. Retry and catch are built into each state. No custom retry code needed. Standard workflows, long-running, up to 1 year, durable, at least once. For critical business processes. Express workflows, short duration, up to 5 minutes, high throughput, for high-volume event processing. Event-driven architecture uses services like SNS, SQS, Lambda, and Event Bridge to decouple systems around events rather than direct calls. Use Step Functions when the coordination of steps is itself complex and when auditability matters. Exam tips SAA CO3 domain. Design resilient architectures, Domain 2, Task 2.1. Step Functions use case signals. Orchestrate multiple Lambda functions. Workflow with retries and error handling. Human approval step in an automated workflow. Audit trail of each workflow step. Step Functions. Standard versus Express. Standard for long-running, auditable, business-critical workflows. Express for high-throughput, short-duration event processing. SQS versus Step Functions. SQS for simple task queues, producer-consumer. Step Functions for multi-step workflows with complex logic, retries, and state tracking. Event Bridge signals. Route events from AWS services to targets. Event-driven integration between services. Schedule a Lambda function. Event Bridge, formerly CloudWatch Events. Callback pattern. Step Functions can pause execution and wait for an external callback. A task token. The worker calls back when done. Useful for long-running ECS tasks where you don't want Lambda's 15-minute limit. Direct SDK integrations. Step Functions can call AWS services directly, DynamoDB, S3, SQS, etc., without going through Lambda. Reduces cost and latency for simple service calls. Exercises. Exercise 1. Recall, explain why Step Functions is useful for multi-step workflows. What does it provide that a simple Lambda function calling other Lambda functions doesn't? Hint. Think about what happens when step 3 of 5 fails in each approach. How do you know what happened? How do you retry only step 3? Exercise 2. Exam practice scenario. A financial services company processes loan applications in multiple steps. credit check, income verification, document validation, underwriter review, manual, and decision notification. Each step can take anywhere from seconds, credit check, to days, underwriter review. The company needs a complete audit trail of every step for compliance. Failed automated steps must retry automatically. Manual steps must pause and wait for a human decision. Which service best meets these requirements? A. AWS Lambda functions chained together with SQS queues between each step. B. AWS Step Functions standard workflows with a wait for callback pattern for the underwriter review step. C. AWS Step Functions express workflows for the automated steps and SQS FIFO for the manual step. D. Amazon Event Bridge with event rules routing between Lambda functions for each step. Hint 1. Up to days duration. Which step functions type supports this? Hint 2. Wait for a human decision. Which step functions pattern is designed for this? Hint 3. Complete audit trail for compliance. Which service provides per execution state history? Explanation. Step function standard workflows can run up to 1 year, supporting the days-long underwriter review step. The wait for callback pattern pauses execution at the underwriter step with a task token. When the underwriter makes a decision, they call back with the token to continue the workflow. Standard workflows record every state transition. Complete audit trail for compliance. Why not A? Lambda chained via SQS provides no built-in state tracking or audit trail. Failed steps require custom retry logic. Restarting from a specific failed step requires custom implementation. Why not C? Express workflows have a 5-minute maximum duration, incompatible with a step that can take days. Why not D? Event Bridge routes events between services, but doesn't maintain workflow state or provide built-in retry audit. Building this on Event Bridge alone requires custom state management. SAACO3 domain, design resilient architectures. Task 2.1, Exercise 3, Architecture Challenge optional. Nimbus is building a food quality dispute resolution process. When a customer reports a bad experience, 1. The report is automatically validated, checks if the order exists, if it's recent enough. 2. The restaurant is automatically notified. 3. A Nimbus support agent reviews the complaint. Manual step. Can take 1 to 3 business days. 4. Based on the agent's decision, issue refund, Lambda payment processor, or send apology coupon, Lambda coupon service, or escalate to management, step function subworkflow. 5. Customer is notified of the outcome. Design this as a step functions workflow. What state type handles each step? How would you handle the 1 to 3 day wait? How would you model the branch at step 4? There is no single correct answer. The goal is to practice step function state design. Post-credit scene. The restaurant onboarding workflow was live. Over the next month, 12 new restaurant partners onboarded. 2 had failures during the payment processing step, step 3. In both cases, step functions captured the exact error, saved the state of the execution, and sent an alert to the Nimbus team. Leo fixed the root cause, a misconfigured API key for the payment provider, and retried both executions from step 3. The executions completed in 23 seconds each, picking up from exactly where they had failed. No restaurant needed to be re-imported. No IAM roles were double created. No duplicate welcome emails were sent. Before step functions, Leo told Maya, this would have required someone to manually track what had and hadn't been done for each restaurant, and manually rerun the missing steps. And now I click retry in the console. The system knows what's done. Maya thought about this. That's not just a technical improvement, she said. That's the difference between a process that scales and one that doesn't. In the next chapter, what to do with data that you're not accessing right now, but definitely want to keep forever.